Okay, so let's start about thinking about how you get what you get when you multiply these out. So x plus y to the power of 0, well, anything to the power of 0 is just 1. X plus y to the power 1 is obviously just x plus y. X plus y squared, if we multiply that out, we get x squared plus 2xy plus y squared. X plus y all cubed, if you were to multiply that out, you'd get x cubed plus 3x squared y plus 3xy squared plus y cubed. And x plus y to the 4, you'd get x to the power of 4 plus 4x cubed y plus 6x squared y squared plus 4xy cubed plus y to the 4. And what we spot is that when we keep doing this and keep multiplying it out, the coefficients, so here it's a 1, it's 1 and 1, it's 1, 2 and 1 of these, 1, 3, 3, 1, 1, 4, 6, 4, 1. They form what's known as Pascal's triangle. So they form a triangle that kind of goes like this. And those give us the coefficients if we keep multiplying out. So if we were to multiply out x plus y to the 5, then you can see these would be the coefficients. And as we do it, we start with x to the 5, then the next term would be x to the 4y, then the next term would be x cubed y squared. So the powers of x are going down and the powers of y are going up. The first term, we have 1 of them. The next one, we've got 5 of them. The next one, we'd have 10 of them. So because of these, 1, 5, 10, and obviously this would continue if we were to keep multiplying that out, knowing your coefficients. So we could just write out Pascal's triangle for every single value we want to find, but obviously that's going to get quite complicated as we get up to bigger numbers. So one way of working this out is to say that the row, and let's choose this row, the 3, this row can also be found, rather than working down Pascal's triangle, this row can be found by saying that each of these is 3c0 is the first one, 3c1 is the second, 3c2 is the third, and 3c3 is the last. And we can also write those, if you remember when we did this in lessons, they are sometimes written like that just for ease or to make it easier. And these values can be found on your calculator, or the general rule for any NCR value is that it is n factorial over r factorial times n minus r factorial. So let's say I want to do the first few terms of this expansion. So the first thing I would do is say, right, if I'm multiplying this out, the first term I'm going to have 2x to the power of 6, and I'm going to have no y's, and my coefficient is going to be 6c0. The second term I'm going to have 2x to the power of 5 and y to the power of 1, and my coefficient is going to be 6c1. The next term I'm going to have is going to be 2x to the power of 4. I'm going to have y squared, and my coefficient is going to be 6c2. And I could keep going, but those would be my first 3 terms. And all I need to do now, if I want to work these out, is simplify it. So either onto your calculator, you can work out 6c0 is 1, and then this 2x all to the power of 6. That 6 is also to the 2, and 6 to the x. So if we take 6c0 is 1 and 2 to the power of 6 is 64, the first term will be 64x to the 6 plus, okay, next term, so 6c1 is 6, that this value is going to give us a 6. That 2 is also to the power of 5, so 2 to the power of 5 is 32, x5, y1. So the number part is going to be 6 times 32, which is 192. So we're going to have 192 x to the 5y plus, And then the next term we're going to get 6c2, which is 15. And then 2 to the power of 4 is 16. So we're going to have 15 times 16 and then x4y squared. And that one comes out as 240 x4y squared. And so on. We could keep working down that expansion as we go.